Hey guys, I'm back. This is going to be part 2. I'm going to do the Moby stuff. Hopefully it works. Okay, number 6. First step, we got to take the antiderivative. Okay, again, we're going from 0 to 2. It's our graph. Started at 0, went to 2. Area in between the x-axis and the graph. Alright. The antiderivative 4x. So it becomes 4x, 1 plus 2, or I'm sorry, 1 plus 1 is 2. Divide by our new exponent, which is 2, minus x to the 3 plus 1 all over, our new exponent, 3 plus 1. And then we're going to evaluate that from 2 to 0. Okay? So again, that's 4. That's 4. This is 2. Make your life easier. So when we plug in, we get 2 times 2 to the 2 minus 2 to the 4th to the 4. That whole thing minus when we plug in 0, which is just going to be 0 minus 0. That's nice. So that becomes 8 minus 2 to the 4th over 4 is what? 2 to the 4th? 2. Maybe wrong. 2 to the 4th. That same as 2 to the 3rd. Oh, derp. So that's 4. So the answer is 4, which is pretty close to our estimate of 3.75, right? Right. The beard's grown back and it's itchy. Okay, deal with it. Alright. Boop, did that one. I know this one. Same rule. First things first, we gotta take the antiderivative. So antiderivative 8s to the 3rd is 8s to the 3 plus 1, which is 4. And we divide by our new exponent, which is 4. Minus 12s, 2 plus 1 is 3. Divide by our new exponent, which is 3. Plus 5. This was s to the 0. S to the 0 plus 1 is 1. All over 1. And we're going to evaluate that from 1 to 0. Alright? That's 2. Simplify these, man. Alright? So I guess you could have said 2s to the 4th minus 4s to the 3rd plus 5s. Right? So when I plug in 1, I get 2 times 1 to the 4th minus 4 times 1 to the 3rd plus 5 times 1 minus, when you plug in 0, you get 0. It's kind of anticlimactic. So 2 minus 4 is negative 2, plus 5 is 7. Alright? Alright. Guys, that was 2 minus 4 is negative 2 plus 5, which is 30. Phew. How many people are like, Mr. Lawrence? Alright, that's reached. Alright. So first things first, we're going to take the antiderivative. So that becomes y to the negative 4/3 plus 1, which is y to the negative 1/3. We divide by our new exponent, which is negative 1/3. Which, if we simplify, we move the 3 up top. Right? So we get negative 3y to the negative 1/3. We're going to plug in 27 and 1. So you do negative 3 times 27 to the negative 1/3 minus negative 3 times 1 to the negative 1/3. Okay? So when we do that, if you don't remember how to do this, last things, negative 3 over 27 to the 1/3. Cube root of that is 3. Minus 1 to any power is 1, so we don't really worry about that. So you do plus 3. So you get negative 1 plus 3, which is 2. Arithmetic. Again, I did this because it's negative 3 over 27 to the 1/3, which 27 to the 1/3 is 3. It's the cube root of it. Alright, on this one, you should know that that's a circle that goes from -2 to 2. We're finding the area of a quarter of it. So my radius is square root of 4, which is 2. So I do pi times 2 squared, get 4 pi. So now I'm only doing a quarter of it. So because I'm only doing a quarter of it, I'm going to divide by 4, and I get pi. Ta-da! Pi. Anyway. And this one, when you graph it, you end up with 2. That's not acceptable, Mr. Familiar. You end up with 2 triangles, right? It says absolute value of x function. So we go over 8. So we get an 8 by 8 triangle, and we get a 4 by 4 triangle. Area of a triangle is 1/2 base times height, so we find the area of the first triangle. So when you do that, you get 8, I do believe. We add that to the area of the second triangle, which I do believe is 32. You add together your two areas, you get 40. Keep checking myself, make sure. Yay! We did that one I talked about. This is what I want to talk about for a second. 2 ways to it. This is kind of the book way, and there's a way Mr. Williger is going to talk about. So you're taking the derivative of this in terms of why not. You're pretty much changing the variables. Okay? So before, let's take the antiderivative. The antiderivative of this, and then you take derivative, it's going to be 1 over x squared plus 1. Because we're just plugging in. You're kind of getting rid of these and putting in terms of x, all that good jazz. And you're going to evaluate it from x to 2x. Use this a little bit differently. So I'm going to plug in 2x wherever there's an x. Alright? So you get 1 over 2x squared plus 1. And then I have to times that by the derivative of that based on the chain rule. I'm going to subtract when I plug in x. Alright? I feel like I actually left the t in there if that makes you feel better. Okay? And that's it. That's your answer. You just do it twice. You do it when you plug in the 2x, and you do it when you plug in x, and you subtract it. Alright? That's it. Get ready for the test. Ask me questions. Come and see me. I'm not a bad guy sometimes. Most of the time. Rarely. See ya.